Many students have told me that this is objectively the most brutal P4 paper of all time. Is it true? I don't know yet, because I kept it for this walkthrough, which again, I'm going to blind solve this paper without having seen it before, also timing myself. So if you haven't seen the paper before, maybe you should download the paper in the description. I know some of you might be going to college soon, although you might not want to subscribe. Please give me a like at least. But for those of you who are still doing A-level, you should be subscribed because I'll be expanding my videos to cover further maths and also physics as well. So please guys, support me. Okay, here's the paper, and of course as you can see, I'm going to be timing myself. I'm a bit excited for this paper. Let's see how difficult it actually is, and I'm gonna hit the timer now. Okay, so let's go guys. Number one, gonna be writing in here as well. Okay. Number one, the curve has equation that the point P with coordinates 1/2 lies on C. Find two possible y's coordinate of P. So we are given that the x coordinate is just 1/2. Now we're going to use that to solve for y, alright? So this is probably not too hard. So 2y squared minus 6x is 1/2, and y is y equals 7e to the, if we put 1/2 to the 2 there, we get 1 minus 1, so this is 0, plus 13. We're solving for y there, right? So y squared minus 3y, e to the 0 is 1, so that's 7 plus 13 is 20, so we minus 20 here. Well, as for my style, I'm just gonna factorize this. Let's see. So 5 and 4, does it work? 5 and 4, nope. 4, 10 and 2 maybe. 10 and 2, 10 and 2, nope. Is it? Okay. Let me use the calculator. All right. So I'm just gonna do. You guys also can, right? So that's not too unfair, I guess. So 2 and then minus 3 and then minus 20. Minus 20 there. Okay, so this is 5/2 and 4. Let me check that. Minus 5/2 and 4. Minus 5/2, so it's going to be plus here, and 4. So that. How did I miss that one? Okay, it's 5 and minus 8, yeah. So y is equal to minus 5/2 or 4. Okay, let's see. Let's see how possible that is. So point P lies on the x coordinate, lies to C. Okay, so it seems like point P here having the x coordinate, and then A asks for two possible y coordinates of P. So that is just the answer there, two possible values. Part B. Given that P lies above the x-axis, okay, lying above the x-axis mean that y is greater than 0, right? Y greater than 0, so y equals 4 there. Find the equation for the tangent to C at P. Give me your answer in the form of that. Alright, so seems like we need to differentiate, right guys? So we do implicit differentiation here, alright? Differentiating implicitly the first term, y squared, 2y squared, so we get 4y. Yeah, differentiating as if it were an x. And then we just do a chain rule dy by dx. Minus, well, gotta be careful here, 6xy, you need to do a product rule. So I'm just gonna do 6x and differentiate the y first, so dy by dx. There is a minus sign here. And plus, product rule, 6x differentiated, we get 6, and then keep y the same. There you go. Okay? Alright, just checking here. Yep, equals, on the right side we differentiate the exponential, so we keep the power of the exponential the same, and now we differentiate the power, yeah, which is 2, multiplying in front, here we get 14, and 13 goes away. Alright, now we want to find dy by dx, right? But you actually don't need to make dy by dx the subject yet, because the math here, the algebra here might be a little time consuming to tidy up. So what I would do is just sub y equals 4. And what was the x? X was 1/2, right? So I'm going to sub these two values into the form. So y, 4y times 4 there. and dy by dx minus, so here I'm just going to expand the minus, so I get 6 times x, which is 1/2, dy by dx, also minus 6y, so 6 times 4 here, equals 14 e to the 2 times x again. 2 times x is, and minus 1, we're going to get 0. Yeah, so that becomes 1. Okay, so 16 here and 3 here. 16 minus 3 is 13. dy by dx minus 24 equals 14. Yeah, so dy by dx is just 24 plus 14 is 38, so that is 38 over 13. That doesn't look so nice, right? Okay. And then we do y minus y1 being 4 equals m, which is that. Wait, is the tangent? Yeah, it's a tangent. I'm just checking. X minus x1 being 1/2. I'm gonna multiply everything by 26 because it's the lowest common multiple between 13 and 2. Yeah, if you multiply across by 26, we're gonna get 26y there. 26y minus, what's 26 times 4? Well, let's get out that mode first. 26 times 4, oops, hang on. 26 times 4 is 104 equals, so 26 times 13, we get 2 there. In 26 times 38 over 13, we get 2. And then when 2 multiply in, yeah, we get 38 and then 2x minus 1, right? So you're going to have 26y, and then we need that form. So 38 times 2 is 76, so minus 76x. And then that's minus 38 as well, so minus 38 minus, plus, so we're going to get minus 104 plus 38, that's minus 66. All right. This form looks a little weird, so I'm just gonna check, yeah. From the beginning, maybe. With my coffee, of course. Above the x-axis, yeah, we picked the right y there. I'm just gonna check differentiation here. So 4y, 6y dy by dx plus just 6y because differentiating x go to 1, and then 14 here, and then plugging in. Okay, 1/2, and then that's 24 minus expands in. 16 minus 3 is 13. 13 minus 24, that's 38. Yeah. Okay, that's 104. Yeah. And 2 times in there, we get that. That is, yeah, I think everything is fine here, guys. 104 plus 38, yeah. Yeah, I'm gonna keep my answer as this, and I'm gonna go to the next question now, number 2. Number 2, a spherical ball of ice with radius r is melting. Okay, this is rates of change. The volume of the ball of ice v centimeter cubed is decreasing at a constant rate. Decreasing here, guys, I note, per second. Given that v is 4 over 3 pi r cubed, thank you. Show that the rate of decrease of the radius of the ball of ice with respect to time is inversely proportional to the square of the radius. All right, interesting. So we are given dv by dt to be a constant rate of k. Okay, where k is a constant. I'm just going to do minus k, yeah? And then we know that v is equal to 4 over 3 pi r cubed, right? We are told to show that the rate of decrease of radius, right? So it's actually dr by dt, isn't it? And now we have v, r, and t. So if we want to link all of them together, we're going to link by what's called the chain rule equation. So it's just dr by dv times dv by dt. Yeah, so basically you could cut out the dv to get back to dr by dt, but The point here is that we want to take all the v, the t, the r to the same picture here in this equation, right? Because this is already told to be k, and this, yeah, is just obtained by differentiating that. So here we have dv by dr is just going to be, actually, it's just 4 pi r squared. So you might recall that this is the formula for the surface area of the sphere, right? And that is just dr by dv by dr. So dr by dv is just 1 over that, right? Yeah? And we're going to plug everything in. So 1 over 4 pi r squared times dv by dt is just minus k. Okay? So show that the rate of decrease of the radius of the ball of ice with respect to time is inversely proportional to the square of the radius. Yeah, you know, we got it. Actually, that's not hard. So it's just minus k over 4 pi times 1 over r squared. Yeah, and this is just dr by dt equals some constant times 1 over r squared. So it means that this is proportional to 1 over r squared, right? And k over 4 pi is a constant, right? So that means therefore dr by dt, or the rate of decrease, we have a minus here. So the rate of decrease of radius is inversely proportional to the square, which is the r squared there, of radius. That's it. This is not bad, guys. Just know how to do it, yeah? Okay, next question, number 3, right? Number 3, given that y equals 4, x equals pi over 6, solve the differential equation. All right, giving the answer in the form of that. This is not too bad. Okay, so solving differential equation means that we need to do integration by separation of variable. All right, so we're going to put dx to the x side, and seems like we also have sine and cos together there. So we have y dy here, and then equals 3 sine 2x over cos squared 2x. And this is dx here, yeah? All right, just checking here. Okay, so integral that, okay? So on the left side, of course, we have y squared. On the right side, let's see, interesting. Aha, but I spot something useful. And again, if you haven't seen my video on how to do reverse chain rule in P3, and it's going to be very useful in P4 here, I'm going to use it. So go check out that video, right? So we're going to use reverse chain rule because I spot this. Well, let me just tidy up the things here, because you have cos 2x to the power of minus 2. There you go. Yeah, that's what I spot. Okay, now you can do reverse chain rule as well, or I think actually you could do a sectan, right? I'm going to show you 2 methods, right? And let's see if they all work, right? Okay, so first here, if you notice, if I differentiate, so n being minus 2 here, if I differentiate the cos 2x, I'm going to get a minus sign, right? So let me write here d by dx of cos 2x. I get a minus sign 2x, and then times 2, right? Outside there. Now, it's not exactly sine 2x here, so I need what's called a correction factor by just multiplying by minus 1/2 to get it to just 1. I'm not doing anything with the 3 there. Yeah? So that means this guy will be our correction factor after integration. We're going to use that reverse chain rule formula. So if you see on the side, you have derivative of fx and then fx to the power of n, like that. You're going to try fx to the power of n plus 1 over n plus 1 with the correction factor there. All right. So I'm going to keep this formula for you there, somewhere around here. yeah? And then we're going to use it. So y squared will be equal to 3. So that's going to be minus 1 over 2, yeah? And then you have what? Cos 2x, yeah? To the power of minus 2 plus 1 over minus 1, because minus 2 plus 1 is minus 1. So y squared is just, if I take the minus sign out, right? This is indefinite integration, so that's fine. If I take the minus sign out, I get 3 over 2 here, and then times 1 over cos 2x here. Yeah, so that's y squared. Maybe a plus c as well. So this is basically y squared equals 3 over 2. 1 over cos is sec, isn't it? So that would be the answer by the first method. All right, let's see the second method, because I just spot that we could also use some trick identity. So this is method 1. Let's do method 2, right? So y squared equals, okay, so I spotted that this could be rearranged as cos squared down here, but I split into two terms, so sine over cos and another cos 1 over cos 2x here. And if you look at the formula sheet, if you're not that good with memorizing all the calculus standard formula here, well, we are integrating what's called here sine over cos is tan 2x, and that's just sec 2x, right, dx. So we can see what differentiating what give you sec tan, right? Differentiating sec give you sec tan. That means integrating sec tan would give you a sec, right? It's just a reverse operation here. So that means this is easily 3, and then we have here sec 2x, but you got to do the reverse chain rule because this is 2x, not x. You got to divide by 2 there. So I get exactly the same answer there, right? Just by using the formula sheet there. So you got to know how to use it, yeah? Get back to the paper. And that is just confirming that, aha, I got the right answer here by using 2 methods. Good, guys. Now, let's move on to question 4, all right? Question 4, part A then. Part A first. Write fx in the form of that. Okay, so this is just partial fraction. Well, the numerator has the leading power of 2, so that's just quadratic, so we don't have to do long division here. So let's just split into 5 plus 7x minus 10x squared divided by x minus 1 to x there. Okay, you know what? I'm not going to write it because they already give us the form there. So I'm just going to multiply by the whole denominator here, yeah, on both sides. So you get a multiply by the 3 terms. So a over x will be left with the other 2 terms, which is 1 minus x and 2x plus 1. Yeah? Let's move things a little bit here. And then for b, we have multiplying the whole thing to 1 minus x, we get x, and then 2x plus 1. And then for c, we have also x, and then 1 minus x, right, for c. Okay, so we substitute all the critical values separately. Well, let's do 0 first. So 0 here, we get 5 on the left side, right? And then I think we're going to be left with just the a. So it's just 1 times 1 there. So it's 1, so a goes 5, all right? And then we sub 1 in, another critical value. So 5 plus 17 is 22. 22 minus 10 is going to be 12, yeah? Okay. And then the a disappears, the c disappears, we are left with the b. So b is 1 times 3 here. So that means b is just 4, right? And then the last substitution here is minus 1 over 2. So minus 1 over 2, okay, so 5, let me just use a calculator here. 5, hang on, 5 plus 7 over 2. Yeah, that's minus actually. I almost got it wrong. Okay, and then minus, so 1 over 2 squared is 1 over 4, so 10 over 4, right? And then I got minus 6. All right, good. Minus 6 equals, so the a and the b disappear, we have the c. So c times 1 minus 1 over 2. And this is 1 minus minus 1 over 2. That's 3 over 2. So what do we get? So 3 canceling, the minus sign disappear there. 3 canceling with 6 on the other side, we get 2. And 2 times 2 times 2 is 8. Right? Yep, I'm happy with that. So I got the a, the b, and the c. So this is just equal to a over, a is 5, 5 over x, plus b is 4 over 1 minus x, plus c is 8 over 2x plus 1. Okay, so that's just the answer there for part A, right? Part B. Hence, use algebraic integration to find the exact value of this. Okay. I mean, looking at the bounds here, guys, okay, we're gonna integrate the whole thing, right? Which is just the whole 5 over x plus 4 over 1 minus x plus 8 over 2x plus 1. So we're gonna integrate the whole lot of that from 2 to 4. Now, I have some experience, anecdotal experience, that when you have, imagine you have to integrate this, right? It's going to be ln of 1 minus x, right? And I had a vague experience of not flipping this, because if you sub 2 and 4 in, this is going to be less than 0. But of course, we know that when you integrate the log, when you integrate and you get a ln, yeah, you have a modulus sign as well. But, you know, I had a vague experience that if you don't flip the sign so that the argument of the log becomes positive, something weird is going to happen. So I'm just going to be safe. I'm just going to try play safe here. So I'm going to flip the sign and putting a minus sign here, yeah? Okay, so I'm just changing it to that, which will work, which is exactly the same thing, don't you think? It's just multiplying the minus at the bottom there, and then we get x plus minus 1, sorry. Okay, so this is going to be equal to 5 ln x minus 4 ln x minus 1 plus this is just 8 ln 2x plus 1, but then we have to divide by 2 there, so this is just 4, right? Yeah, reverse chain rule that. And all this will be sub to the limits of 2 to 4. There you go. Okay. Now, for ln, right, it is easier to substitute upper and lower limits at once together. For example, if you sub 4 into that, you get 5 ln 4. But if you also sub 2, yeah, in and subtract this already with the first set, you get 5 ln 2. Now, why is that easier? Because we can use the log property to merge the ln 4 and the ln 2, right? So all of this will become, yeah, when you do the substitution, 5 ln 4 over 2. Now I need to write just 3 terms, okay? So minus ln, so the top bit will be 4 minus 1, which is 3, and the bottom bit will be 2 minus 1, which is 1, okay? Oh, that's 4 there, I forgot. Okay, and then plus, what's the other one? 4, and then 4 times 2 is 8, so that's ln 9, 4 ln 9 over 2 times 2 is 4, 4 plus 1 is 5, yeah? So that's it. And we simplify, so let's see. It's ln 2 and ln 3 over 5. Yeah, bam, we got it. So 5 ln 2, and this is plus 4, yeah? And I'm going to do, okay, so this is, well, you can merge the 4 there. So it's ln 4, and then you have 9 over 5. Because these are adding together as well. So we have 9 over 5 divided by 3, right? Yeah, because it's a minus 4 ln 3 there, so you divide the 3 into the argument there. Okay, and if we simplify this, we have 5 ln 2. So this is, yeah, this is plus 4 ln 3 over 5. That is just as required, right? Yeah, I think I'm happy with this. So I'm done with number 4. Next, number 5. Where's my number 5 here? Okay, number 5 is here. Number 5, the curve C has parametric equations. X equals that, t is not 1, of course, you can't divide by 0. The point P where t equals 2 lies on C. A, use parametric differentiation to find the equation of the normal. Okay, so first step, we need to do dy by dx for part A here. So that is just parametric differentiation, okay? So dy by dt over dx by dt. Now dy by dt is just 0 minus 2t, so that's minus 2t, yeah? Don't forget the minus sign. Dx by dt seems like we need to use what's called the quotient rule, right? So quotient rule dx by dt, I'm just going to write this first. So v is the bottom bit, u is the top bit. So we do v du. Du is differentiating 3 plus 2t, so we get just 2 there. V du minus u dv, so dv is just minus 1, right? Differentiating the bottom bit, you get minus 1. And then keeping the top bit the same. That's u dv. V du minus u dv divided by v squared. So that's 1 minus t squared. Okay? So, well, you know what? Let's just, yeah. So let's also do dy by dt here as well. I'm just going to have minus 2t. All right? And then, so when t equals 2, I'm just going to sub in separately here, guys. When t equals 2, dy by dt is minus 4, right? That's when t equals 2, because it says point P where t equals 2. And then dx by dt will be what? Well, you sub in all here, right? So that's going to be, I'm subbing in 2 in this, yeah? So I get minus 1 here, that's minus 2, minus 2. Well, you know what? Let's simplify the expression first, just in case, because they might look for the method mark here. Okay, so that's 2 minus 2t minus plus there, so 3 plus 2t, right? Or divided by 1 minus t squared. So that is just 1 plus t, yeah, divided by 1 minus t squared. Ah, nice, okay. And then subbing in 2 in there, we get, on top we get 3 divided by 1, right? 1 minus 2 is just minus 1 squared. Yeah, so that's just 3. So this is just then minus 4 over 3. Yeah, for the derivative there. But note that we want to find the equation of the normal. So we got to flip that. So equation of normal, gradient of normal, mn, is just flipping that and put the minus sign. So that's 3 over 4. Now we need the x and the y. So the x at this point P is substituting t into the x here. So that's 2 subbing in. We get 3 plus 4 over 1 minus 2, right? Yeah, subbing in t equals 2 in there. So that is just minus 7, and y equals 1 minus t squared. So that's just minus 3, right? Okay, I'm checking. Yeah, I'm very careful. Okay. Yeah, I think I'm happy with that. So now we form the linear equation y minus y1 equals m x minus x1 there. So multiplying 4 on both sides, we get 4y plus 12, because that's the plus 3 there, equals expanding the 3 in, so we get 3x plus 21. Okay? So my linear equation would be, let me shrink down here. My linear equation would be, we got to do everything on the same side, right? So 3x minus 4y, and then 12 subtract 21, we get plus 9 on the other side. Yeah, so that is just it for part A. Part B, show that the Cartesian equation for C can be expressed in that form. Okay, let me sip coffee. Well, okay. Let me think. So that is 1 minus t and 1 plus t, right? Interesting. Well, we can make t the subject from the x parametric x equation there. And then we sub back into the t squared in the y. How about that, right? Is there any better way? I don't see it yet, so I'm going to go with that. So multiplying 1 minus t into the other side, we get x minus xt, right? Equals 3 plus 2t. And then we're going to make makes t the subject, so we merge the 2t plus xt, and 3 goes to the other side, we get x minus 3, yeah? So t equals x minus 3 divided by x plus 2, yeah? Just factorizing t out there and make t the subject. So that means y equals 1 minus all this squared, right? Okay. Well, yeah, it's not the same yet because they merged the fraction. So we have here, we got to multiply x plus 2 squared here. So we get this. And the bottom bit will be just x plus 2 squared. Yeah, it's like you split the x minus 3 squared and the x plus 2 squared into fraction a over b and just do the fraction thing. Okay? Now, because here you don't need to expand actually, it's probably easier if you do like, well, you see that as a squared minus b squared, right? Which is going to be equal to a plus b times a minus b. Do you see that this is like an a and this is like a b? So we can do x plus 2 plus x minus 3 there, yeah? And x plus 2 minus x minus 3, yeah, like that. So that's just like a plus b and a minus b. I would like to do it that way usually. Okay, if I see this applied, yeah. Okay, so the first term is just 2x minus 1, and the second term on top there is just disappearing, x disappears. So we get 5 here. Okay, and this is just x plus 2 squared. If we expand the 5 in, yeah, we get 10x minus 5 divided by x plus 2 squared. Everything is an integer, right? Yep, they are. So k to be found. So x is not equal to minus 2. Yeah, we need to note that first as well. So p equals 10, q equals minus 5, r equals 2, and k equals minus 2. Because that cannot be a division of 0. So I will keep my answer like that, guys. Next, number 6, right? Here. Vectors. Okay. Relative to a fixed origin, a point A has position vector of that, point B has position vector of that. The line L passes through A and B. Write down the vector equation for L. Okay, vector equation for L. Write down? Okay. Yeah, we need some calculation here. It's not like it's too obvious so that you can answer already here. But yeah, usually R equals A plus lambda B. The vector B here is called a direction vector. You can do it by you can take it by using AB here. So it's just going to be 5, 2, 1 minus 1, 2, minus 3 here. Yeah. Okay, so that is just 4, 0, 4, right? Okay. So A can be anything. I'm just going to take the A, right? So R here, the equation vector of the line is just 1, 2, minus 3. Hang on. 1, 2, minus 3 plus lambda 4, 0, 4. Okay? I'm just going to answer like that. Part B. Given also that the point C has a position vector of that where alpha is a constant, points A, B, and C form the triangle ABC. Okay, so AB is already on the line here. Let me just draw out because I would like to draw. But C is probably not on the line, right? So C is here, ABC is a triangle. Angle BAC is 45, so it's about maybe there, yeah? We have a triangle here, and this is 45 degrees, BAC. Find the exact possible values, maybe more than one, of alpha. All right. Yeah, so we can do dot product here. So if we dot AB and AC, we should get BAC being 45, right? So cos 45 degrees here is going to be equal to AB, which is already found. We found it earlier. Good, yeah. So 404 dotted with AC. We haven't got AC, so let's find it first. So AC is just C minus A. So it's just 3 alpha and 5 minus A, which is 1, 2, and minus 3, isn't it? Hang on. Okay. Yeah, just checking. Yep, happy with that. And then this AC will then be 2, alpha minus 2, 5 minus 3 is 8. So 2, alpha minus 2, 8. Interesting. Okay, and then down here we also have to find the magnitudes of two vector. So this one is just 16 plus 16 times the other one will just be 4 plus alpha minus 2 squared plus 64. That's a lot of algebra there, guys. But fear not. Cos 45 is 2 over root 2. Actually, no, root 2 over 2. Yeah. Equals 4 dot 2, we get 8. 0 dot that disappears. So 8 plus 4 dot 8, we get 32. Easy for that. And then this is root 32 here. So root 32 is basically, what was that? Okay, 16 times 2, which is 4 root 2. Yeah. And then multiply. Well, that's a little complicated there in the square root. So we have 68. Maybe I'm gonna keep this as alpha minus 2 squared plus 68 first. And hopefully that will simplify. Okay, so multiplying across, yeah, I get, so multiplying up there, I get 4 times 2, yeah, this is multiplying that, so I get 4 times 2, divided by 2, I get 4 here, 4 with all that square root. And then the other side would just be 40. 4 can cancel 40 to 10 here, all right? Let's double check everything. Yeah, I'm happy with that. And then let's solve this one. So we square both sides. We get alpha minus 2 squared plus 68 equals 100. Right? So that's fine. Yeah? Well, we can solve this just by using completed square form here because we already got it. So this is 32. So there was a good reason why I didn't expand that, right? I mean, probably, fortunately. And then alpha minus 2 here would just be plus or minus square root 32. Remember, when you take the square root on both sides, you need to do plus minus. So alpha would just be plus minus. Root 32 is again 4 root 2, isn't it? My plus 2. So that would just be 4 root 2 plus 2 or minus 4 root 2 plus 2. Exact possible values of alpha. I think I got it. There you go. Exact possible values. Yeah, that's it for vectors. Not that bad. I'm still 38 minutes here. All right, so next one is number 7. Ooh, look at that. Charming. Okay. See, what do we have here? Okay. Okay, substitution. Part A show that the substitution u equals tan x transform that to that. All right, guys, we just do du by dx first then. Differentiating tan, we get 6 squared x, okay? And then we're going to transform that whole thing. So before doing anything, we should do dx as a subject here first. So that's going to be du over 6 squared x, right? Okay? And then let's put dx as du over 6 squared x first, because that's just to see if there's any cancellation. But doesn't seem like there is, so I'm not gonna do that yet. But okay, I see something here. If I put 10 outside, 10x here, and the inside will be just 1 plus 10 squared x, right? Isn't it? That's a bonus, because 1 plus 10 is just sec. 1 plus 10 squared is sec, so it's gonna cancel there, guys. And 4 plus 6 squared x, well, isn't that just yeah, let's keep this first. All right, okay. And then this will cancel, right, because they're equal. And then 10 will be u on there. Okay, now we have the u there. That's smooth. And then 4 6 squared, well, guys, interesting one here. Let me see. So 6 squared, right? 6 squared x is also, again, 1 plus 10 squared. That is just, okay, I'm just going to write 1 plus 10 squared x. But we sub u as 10x, so this is 1 plus u squared, right? So that is 1 plus u squared. Yeah, I think that's fine. So we have u here over 4 plus, subbing in the 6 squared there, we have 1 plus u squared, and to the power of 3 here, du. Okay? So I think we got it. I think that's it. So integral u over 5 plus u squared to the power of 3. Okay? Yeah, I think I'm happy with that. Yeah, so the n here is 3 already. Yep. And then hence find the integral of all that. So just the same thing. Now, what is this? Well, again, guys, that video will tell you that if you make this, okay, let's tweak the form first. So it's u and then 5 plus u squared to the power of minus 3 du. And this is the same reverse chain rule integration. Do you see? I don't need any more substitution work. You could try do by parts or substitution. It might or might not work, but for sure this is reverse chain rule. So go check that video, please, if you don't understand what I'm doing. So because if you differentiate the inner function here being powered by minus 3, you're going to get around the same kind of function u. So we can try that. Differentiating d by du of 5 plus u squared, you get 2u. Now it's not exactly the same as the outside function yet, but we can use a correction factor. So we multiply by 1/2. So we get exactly the same as u there. And this will be the very correction factor we seek. Okay, so all that will just be equal to, the inner part, which is 5 plus u squared, to the power of minus 3, but plus 1, and divide by the added power, minus 3. And then the correction factor is just 1 over 2 here, yeah? And that's it. So this is a plus c here. That's it. In terms of u, we got to change it back to x later. I made that mistake before. I'm not going to make it again, guys. Okay. So what is all this? It's 5 plus u squared to the power of minus 2, all divided by, that's minus 2 times 2 is minus 4. So I'm just going to do minus 10 and 4 here. Yeah. All right. Just checking. Yeah, I think I'm happy with that. Now, we got to put this back into the x form. Okay, so we remember that u squared was 5u squared there was this same guy, right? So we got this guy from this guy and from this guy, and that was from this guy. It's the 4 plus 6 squared x. Yeah? So this is just equal 4 plus 6 squared x to the power of minus 2 over 4. Right? So that is just minus 1 over 4 times 4 plus 6 squared x to the power of 2 plus c. So I mean, that would be my answer actually. Let me check actually, yeah? So let me check everything. Yep, I think I'm happy with that, guys. Yep, I think I'm okay. That would be my answer there. Am I actually okay with this? Let me give me 1 minute. Yeah, I'm gonna check everything quickly. Yeah, I think I'm happy. So next question, number 8. Part A. Find in ascending powers of x the first 3 non-zero terms of the binomial series. That's not too bad, right? So first we gotta know that this is 4 plus x to the power of minus 1/2, right? And then you need to do 4 and then 1 plus x over 4 to the power, all to the power of 1/2. Just take 4 outside first and put everything to the minus 1 over 2 there. And then 4 to the minus 1 over 2 is 1 over 4 to the half. 1 over 4 to the half is just 1 over root 4. That's just 1 over 2. So this is 1 over 2 here. And then now binomial expansion, guys. First term is 1. Next term is n, which is minus 1 over 2, and x, which is x over 4. Okay, we are doing the first 3 non-zero term. Okay, and the next one is minus 1 over 2 minus 3 over 2 divided by 2 factorial, which is 2, x over 4 squared. And that's it. That's the first 3 terms. Okay, so this is 1 over 2 first. 1 over 2 expanding into the second term, we get minus x. So it's just 1 over 16x, yeah? Just as a simplified fraction there. Okay? And then, yeah, I'm just checking. And then plus here. So, okay, what do we have? We have 2 negatives here, so they're going to cancel. Good. And then we have 2 here, 2 here, and 2 here. So that's 8. And this is also another 2, so that's 16. And there's another 16 here. So 16 squared is 256, right? And then on top we have a 3. That's it. Yeah? Let me just check my mental math there. 16 times 16. Yeah, 253. Okay, am I happy? Yeah, I think so. Okay, so that's my answer there. I mean, you shouldn't get this wrong, because if you do get this wrong, the later parts will be, you know, collapsing. Like you're going to lose all the accuracy marks, though you got some method marks, but you want to get every mark possible, right? So you don't want to risk losing a lot of accuracy marks. Part B, state the first 3 non-zero terms of the binomial series expansion of that. Wait, using expansion from part A. This is a negative now. Okay. Okay, so if that was a negative, right? If that was a negative, then this will be a negative as well. Yeah? This will also be a negative. So the second term will be, I'm just going to write down 1 over this is just the first 3 terms as well. Yeah? So this will be a positive for sure. Yep. Yeah, I'm just checking. So this will be a negative, right? So a negative times a negative, yeah, will be a positive. So that should be a positive 1 over 16x. What about this one? Well, doesn't matter. This one, negative squared, you get positive anyway. But this one will be the same. So that is just going to be the same, which is positive 3 over 256x squared. Yeah? That's just the answer to part B there. Now part C, hence or otherwise show that blah 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 is about a plus bx squared. All right, so yeah, so I'm just going to write about there. We're going to multiply the two things. Okay, so interesting. Let me see. Okay, let me think a bit how to go with this. Yeah, because the only term that is different is that and that, right? So I mean, okay, yeah, let's multiply that all out. So I'm just going to write down here everything first. We're going to multiply that with that, yeah? Okay. And that's going to be, yeah, I'm just going to do the same sign there, approximation. Okay. So the first term times the first term, you get 1 over 2. Yeah, sorry, 1 over 4 actually. All right, that times that. So that times that. The first times the second, we get plus 1 over 32x. The first times the third is still a quadratic. Yeah, so it's 3 over 512, right? Yeah, x squared. All right. And then we're going to do the second times the other 3. So the second term here is the minus 1 over 16. The second term times the first term, we get minus 1 over 32x. The second term times the second terms, we have minus 1 over 256 x squared. Yeah? And the second term times the third term is not going to be applicable here because we just want up to the quadratic degree or the second degree. So we're going to ignore that. Now let's do the third term times the first term, the new set there. So we have plus 3 over 512 x squared as well. So the third term times the second term and the third times the third will be ignored because it's more than degree 2. And we're going to simplify all this. So the first term remains the same. The second term, well, that cancel that, isn't it? Yeah? Okay, so we have what here? This is basically 2 over 512, right? So we have 3 and 3 here, so that's 6. And this is minus 2, so 4 over 256 x squared. Yeah, am I happy with that? I think I am. A and B are simplified fractions. So can this be simplified? So 4 times 6 24, yeah. So that's just 1 over 4 plus 1 over 4 6 and then 4 4. Yep. Yep, I'm happy with that. So that's just the answer, guys. Part D. Use that equals a plus bx squared with x equals 1 and the values of a and b to find fully simplified rational approximation to that. Interesting. But yeah, we're fine. So we're just going to sub in x equals 1 to both sides. And let's see what happens there. Yeah. A is 1 over 4 plus 1 over 64 times 1 squared. Okay, interesting. So this is 5 here and this is 3, right? So that's 1 over root 15. 5 and 3 multiplied. And we get here 1 over 4 plus 1 over 64. Okay, now let's see. 135, right? If I divide that by 15, no. 135 divided by 15. Aha, I get 9. Haha, can't fool me there. Okay, so that means, right? Okay, if we rearrange, if we multiply by 9, 3 over 3 on both sides, yeah? On not both sides, just that fraction actually. And let's do this fraction here. So it is, yeah, that's 1, right? Yeah. So this is what, 16 over 64, isn't it? Yeah. So that's 17 over 64, right? Yeah, I'm happy with that. So the left side will be 3 over 3 root 15. Well, because I tried in a calculator to see if 15 can divide into 135. And it can. So that means you can do something here. Because if root 135, okay, root 135 is just then root 15 times 9. That is actually 3 root 15, isn't it? Right? That's why I multiplied by 3 and 3. Because I want to create this first. So that this is 3 over root 135, guys. Yeah? Manipulation. Okay? So that means root 135 will just be 64 over 7 times 3. just moving things around there. So 64 times 3, wait, what? 64 times 3. Okay, so that is just 192 over 17. That can divide, yeah. So that is just it. I'm just gonna write that already, yeah. My method is clear, I think. So that is the fully simplified fractional fraction form. Okay, so there you go. Okay, that's it. Next, question 9 now. Question 9, I'm still at less than an hour. I think I'm fine. Okay, figure 1 shows a sketch of part of the curve with equation that. All right, the finite region shaded in figure 1 is bounded by axis is the line with equation x equals 4. Interesting. Okay, so this is solid of revolution. Rotated through 2 pi radians about the x-axis to form a solid S. Show that the exact volume of solid S is given by that. Alrighty. So I'm just going to do here, part A. Exact volume of solid S. Okay, so just the formula there, pi integral y squared dx. Yeah, that's the formula. So what do we have? We have pi integral y squared is just cos x plus 1 over 5 e to the x squared here and dx, right? Just follow the formula there. And the bounds will just be 0 to 4. Okay? Wait, why is that 8? It's like, okay, it's doing, okay. I'm just going to be careful here because, it mentions figure 2 down here. So this has got nothing to do with figure 2 yet in part A. So I'm just going to, no worries. Just going to integrate that. Okay. So equal pi integral. Well, let's expand that, right? So we're going to get cos squared x plus 2 times cos times 1 over 5 e to the x. So it's just 2 over 5 cos x e to the x, right? And then plus, this is just 1 over 5 e to the 2x. Ooh, but you got to have 25 here as well. Almost forgot because it powers both terms there. Okay, so that's all there is, and then dx. Okay, so how do we integrate this? Well, the cos squared, you guys should all know how to integrate that separately. Can we integrate this? Oh, this is brutal, I'm telling you. Okay, so it comes up, this one. It was in my hardest P4 questions there. This is the loop integration. Okay, bingo. And integrating this is easy. So we're going to integrate separately, yeah? So integrate cos squared x, yeah? We're going to use the double angle formula. So cos 2x is just 2 cos squared x minus 1. So cos squared x will just be equal to cos 2x over 2 plus 1 over 2, right? Yeah, so integrate that, we get integral cos 2x over 2 plus 1 over 2 dx. So that's going to be integrate cos, we get sine, be careful, not minus sine. And this is over 4 because we got to do reverse chain rule and it will multiply. And this will be x over 2. Yeah? I'm going to keep that as that first because we're going to do c all at once, right? And this is also definite integration, so we don't need the c there. Integrating this, right? This guy right here, 2 over 5 cos x e to the x. Well, yeah, we're going to do by parts. We're going to do by parts here. And you will see what I'm talking about. So 2 over 5. There. And let's do by parts. So we're going to make this u and this dv. So differentiating cos, sorry, not yet. We got to do, so if that is dv, so yeah, it's easy. V is e to the x as well. So diff u v. So we have cos x e to the x, right? Minus integral. So du is differentiating cos. We get a minus sign, so I'm going to change that to a plus sine x, and v, which is still e to the x dx. Okay, so that's the first step. Now, and then we have what? Well, you know what? I'm gonna take the 2 over 5 away first. Yeah. So we have cos x e to the x, and then that again will be another by parts, right? Because again, this is loop integration. Sorry, what happened there? Okay, right? So that's going to be another by parts where we put it in the whole brackets again. Yeah. Okay. So u v, again, u is easy, sine x. V is also easy. And then minus integral du. Differentiating sine, we get a cos x. And that is also a v again. Do you see something here? So the left-hand side is just cos x times e to the x dx. What is the right-hand side? Well, it's cos x e to the x plus sine x e to the x minus integral cos x e to the x dx. Don't you see, guys, that the thing we are finding is also here? So we can merge the thing we are finding, and this is what I call loop integration. Because if you don't see this, you're going to be integrating forever. It's not going to stop. It's going to be a loop, right? So we move that to the same side. So we call that 2 of them because that is a minus. So the other side here is 2. Cos x e to the x. It's like making it I first. Some people, yeah. So for the right-hand side, I'm just going to, do I need to factorize that out? Yeah, I'm just going to do it. Maybe e to the x, sine x plus cos x here. And then that divide by 2, okay, to get just that. Okay, so I think I got that already. I'm going to put everything back in. So this will then be equal to pi times integral of cos squared x. I remember that I have that, so it's just I'm going to write the integral already. So sine 2x over 4 plus x over 2 for the first set. For the second set, yeah, I remembered I have 2 over 5 as well. And then it's e to the x over 2 sine x plus cos x. Yeah. And then the third term is just integrated easily. Yeah. Wait, hang on. I have a pi in front of everything, right? Pi here. Okay. And then the third term I'm just going to do here. The third term is just integrating 1 over 25 e to the 2x. Well, that's just reverse chain rule. So it's 1 over 50 e to the 2x. That's it. Right? And then I want to prove that this is the case. So this is just going to be, oh, hang on. Wait, what? I think I'm doing, okay. I think I'm doing the wrong part here, guys. I think I already did part B with this, right? So let me actually just take the liberty of copy paste here. I'm just going to do that for part B. Yeah. So this is part B, I think. Sorry about that. This is part B, guys. Okay. There you go. The liberty of copying and pasting. Okay, there you go. And that's part B done. Part A wasn't done properly, so let's do part A again. It's just to show that the integral can be rearranged to that. All right. Okay. Fine. Do we have it already there? Actually, let's see. So I'm gonna keep that. Wait, what? Okay. Yeah. So I'm just gonna delete this maybe. Yeah. No, hang on. I'm not gonna delete that. So this will be pi square root. So cos squared is cos 2x over 2 plus 1 over 2. Yeah. And then we have here 2 over 5 e to the x cos x. I'm just gonna copy down the template there. And plus 1 over 25 e to the 2x dx. Yeah. Yeah, am I happy with everything? I think so. So this is still pi integral 0 to 4 A is going to be this guy here, 1 over 2. B cos 2x is going to be, yeah, the B is just 1 over 2 cos 2x here. Yeah, that's the B. Plus C is just 2 over 5 e to the x cos x. And the D will be 1 over 25 e to the 2x dx. That's everything, right? So that's as required. Okay, now part B we're done. And then I guess, yeah, figure 2 represents the paperweight formed by joining the two of these solids. Using the answer to part A and B, find algebraic integration, the volume of the paperweight, giving your answer to two significant figures. Yeah, we kind of did it here. So cut. And then I'm going to do part C here. Okay, here we go. So that is just integrating from 0 to 4. So this is the volume of 0 to 4. So volume 0 to 4 will be just this. Yeah. Let me squeeze in everything a little bit. Yeah. Oops. Okay. There you go. And that is just already integrated. So let's check the term here again. So I got x over 2 here. That is just integrating cos, we get a sine, and then over 4 there. Integrating that, I already got it to be this, right? Yeah, the e to the x and everything. It was, where was it? Yeah, it was here. Yeah. Yep. And then that's 1 over 50 e to the 2x. Yeah, so if I sub 0 to 4 in, I should get the volume of just one of them. But we need two of them because it's forming two. So this is 1 to 4, and then you have another half here. So you're forming this shape. So we need two of that. Okay. So volume of S, right? This is volume of S, isn't it? Is it called the solid S? Volume of S is given by this. So it's the paperweight, volume of paperweight is equal to 2 times all that, V of 0 to 4, which is equal to 2 pi, and then all that, right? So 4 subbing in. Hang on. Is this in radians? Yeah, that should be in radian, right? It doesn't tell. So everything is in radian. Okay. Yeah, all right. So that's sine 8. Okay, feels weird, but there you go. There. Plus 2, yeah. Plus 2 over 5 e to the 4 over 2 sine 8 plus cos 8. Right. Okay. And then multiply here. And plus 1 over 50 e to the 8. That's just the upper limit, guys. Okay. Now if we sub 0 in, the sign disappears, the x disappears, the sign disappears. So what do we have left? So we just have minus, right? The lower limit. So it's just 2 over 5 there. And so this sign will disappear. So cos 0 is 1. So that's just 1 over 2 there for that term, right? Yeah, and then the other term, 0 subbing in there, we also get 1 there. So that's another minus 1 over 50 because it's a plus, but it's subtracting, so it's a minus. Okay, that's everything. We just simplify that, right? And I'm just going to use a calculator here. So slowly, 2 pi times big brackets here. It feels weird to say, but sine 8. Okay, here we go. Over 4 plus 2 over 5 times. All right, just checking while I press it. In brackets, e to the wait, what? e to the 4 over 2 times sine 8 plus cos 8 bracket bracket and then close bracket again, right? Do I have too many brackets here? No, I think I'm fine. And then plus 1 over 50 times e to the 8, right? Yeah. And then down here I have minus. That's 1 over 5, so that's not 0.2. Yeah. Minus 1 over 50. I think that's everything. Close bracket. So let's see. 2 pi outside everything. Yep. Yep. Because I got 2 from 2 of the solid S and then v from 0 to 4. Okay. Then I have here sine 8 over 4 plus 2. I'm just checking everything, guys. 2 over 5 times the whole thing there. Wait, what? How did I get sine 8? This is not sine 8. We are subbing in 4, right, into this, so it should be sine 4. This was sine 8 because it multiplies by 2. Almost made a mistake there, guys. Okay. Sine 4 and sine 4. But good that I kept everything still, so I didn't lose that. E to the 4 there, and then I have sine 4 here, and also cos 4 here. Yeah? Yeah. Okay. E to the 4 over 2. Wait, there should be... Shouldn't there be like another bracket there? Yeah? Like that. Like this, I mean. Yeah. Okay. Wait, let me check that again. That's a little tricky there, guys. Okay. Okay, you know what? I'm gonna take out the brackets here. Wait, no, I should keep it. Yeah. This is sine 4 plus cos 4 and then brackets. And then multiply with that. And then close bracket because we need to multiply 2 over 5 there all at once. Okay. Yeah, and then I think that's fine. And then plus, give me some time, yeah? Just double checking. Yeah, I think I'm fine. So 1 over 50, 8 to the e to the 8, and then minus 1 over 2 here. Sorry, 0.2 and minus 1 over 50. And then all that in brackets multiplied by 2 pi. So that would be my answer. 290, 2 significant figures, 0.565, blah, blah, blah. So 290. This should be in centimeters cubed. Yeah, giving you an answer. So yeah, volume should have a unit, right? And that is my answer here to number 9. Okay, took some time there. That was it. Next, hope the last one. Question 10. What is that? Use proof by contradiction to show that for all angles x, where 90 less than x less than 180 is that. All right, let's see. Okay, this is interesting, guys. Let me see. Aha, I spot something. Cos 2x is just cos squared x minus sine squared x, right? And this is cos x minus sine x. Okay, I started too soon. I should have assumed first. So assume that for all angles x, where x is blah, 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 this thing, that thing, not that yet, the modulus of cos 2x over cos x sine x greater or equal 1, because the opposite to less than 1 would be greater than or equal to 1, right? So I just got that. All right, so we're gonna start by that first. Yeah. And then this is still greater than equal 1, right? Okay, so what do we have here? Okay. So we can do something like this. So cos x minus sin x times cos x. Well, this is also in absolute, right? Yeah. Cos x plus sin x divided by cos x minus sin x greater than equal 1. All right? Let's see. So we want to contradict somehow that this doesn't work. I mean, look, we could cancel cos x minus sin x, right? If we think about the x here, x is in quadrant 2. Yeah, x is in quadrant 2. I'm just going to write that because it's 90 to 180. That's quadrant 2. Now, quadrant 2, cos minus sine. Cos is a negative value. Sine is a positive value. So negative value minus positive value, you get a negative value, right? So we just think about this separately, yeah? In the range of x less than 180, greater than 90, yeah? Cos x is less than 0, sin x is greater than 0. Okay? Consider each one separately, right? So we have cos x minus sin x is then less than 0, right? It's going to be less than 0 then. And cos x plus sin x, well, you don't know because it could be less than 0, it could be more than 0, depending on which one is greater, okay? But for sure, this is less than 0. So if you have a negative number and a negative number, you can cancel. So that means this will reduce to cos x plus sin x greater than equal 1. Well, or you could just cancel that, right? And this is still in the modulus sign, right? Okay. Let's see. Okay, so cos x plus sin x. One is a negative value. The other one is a positive value there. For all angles, right? Okay, I see. How do we deal with this? Can we square that? I mean, if we square that, right? Yeah, we can square that. So if we square that, we get cos plus sine and then square here. Everything is going to disappear. And then we would have sine squared x plus cos squared x plus 2 sine x cos x, right? How about that? And then this is 1 plus 2 sine x cos x, which is just a double angle, right? So that's just sine 2x greater than 1. So now we are arriving at sine 2x greater than 0. Yeah. Well, sine 2x greater than 0, right? And x is in quadrant 2. So if we think about the 2x there, because we get sine 2x, and x is already in quadrant 2, so 2x will be in between 360 and 180. So 2x will be in quadrant 3. This is in quadrant 3, guys, if you know what I mean. Here is around here. Greater, wait, what? Hang on. This is quadrant 3 and 4, yeah? So it could be anywhere here, the line. But we know that sine 2x in quadrant 3 or 4 is a negative value. So this is not true, right? Aha, we got it. So, so sine of 2x, okay. So sine value of an angle in quadrant 3 or 4 can only be a negative value. Yeah. Therefore, sine 2x greater than 0 is false. Yeah, this is false. And this contradicts the assumption that this is greater than 1. Okay? Because we said it greater than 1 or equal 1, but it didn't work. So this contradicts the assumption that, I'm just going to write everything basically, that what was it, modulus cos 2x over cos x minus sin x greater than equal 1. Therefore, for all angle x in this range, that is true. Yeah? We got it. And that is the last question, guys. Now, because I still have time, I'm just going to take the liberty of maybe double checking everything. This is a good paper. This is a good paper. I think it's not, actually it's not too hard there. It's hard. It's hard. It's not like every question is hard. Well, actually, every question is kind of hard, but not too hard. But I guess that you guys might have run out of time when you did this paper, didn't you? Okay. Oh, I almost ran out of time here. I got 10 minutes left. So I think I'm gonna be careful here and check everything. So you guys might skip this part, but because I'm taking this as a real exam condition, so this is what I would do. So I'm gonna double check everything. Yeah, x coordinate 1/2 there. So if I put 1/2 in there, so y 1/2 minus 1 is 0 there. So this becomes 20. I move 20 here. I factorize that. Didn't see that at first, but there you go. 5 and 10 minus 3. Yep. 4 because that's greater than above the x-axis. So y is 4. X is that. And then I think I checked this ones already. Maybe I'm gonna check the ones that I didn't before. So like this one here. So the rate of decrease of the radius. Okay, volume of the ball is decreasing. That's why I put a negative at the constant rate k. Yeah. And then we do a chain rule. dr by dt is dr by dv, dv by dt. So that's a negative k still. This is the volume of the sphere. If we do dv by dr, we get 4 pi r squared. dr by dv is just the reciprocal of that. And then we have a k here over 4 pi r, still a minus. Yeah, so the rate of decrease of the radius is inversely proportional to the square of the radius itself. That's fine. Next one here. Okay, so I'm just gonna keep this. Next one here. Yeah, so this is separation of variables. So v cos squared there, I move it down. Yeah, and this one I stress to you that you should be able to use reverse chain rule for integration. So you can see this as fx and then the power of minus 2 there. And then we have the inner part being cos 2x, and then that's the power added 1 minus 1. And then the minus 1 here disappears. Yeah. Let's see. Yeah, this might get a little tricky here, but I got the same answer there, so I should be okay. Yeah, let's not check this one. Let's go for this one. Partial fractions there. So I got everything there. 1 minus x there, note. Okay. Yeah. So, and then I put x to 0 first, so these disappear, just be 5 there. And then that and that disappears, so we just got a there as 5. I put that to 1, so this is 22 minus 10. I get 12 here. So that disappears, I get 3 here. So b equals 4 minus 1 over 2 here, and then that goes to minus 6. So let me check that one. This is 10 over minus 10 over 4. That's minus 7 over 2. So that is what? 34 minus 10 over 4. And 5 is just 20 over 4. Wait, what? Hang on. I need to check this one again. 5 minus 17 over 2 plus, no, minus 10 over 4. Yeah, that's right, right? Yeah. Everything is minus that. Minus 6. And then everything disappears except C. So minus 1 over 2, that's minus minus. So 3 over 2 here, minus 1 over 2. So this is going to be 8, right? Yeah. Yeah, okay, 8. And then we plug that into the initial form, making sure that we plug everything in correctly. So that's the partial fraction. Now again, because I would like to flip this to be x minus 1, and then I integrate it, I get that, and that correctly. This is dividing by 2 already, so I get a 4 instead because of the reverse chain rule there. And then I plug the bounds in because the bounds was 2 to 4, right? Okay, so 2 to 4, so 4 and 2, 4 and 2, 4 there, and 2, 4 is 9, and 2 is 5. And then this is 2 here. This is 9 over 5 minus 3, so that's 3 over 5. Yeah, I'm happy with that. This one, okay, parametric. I think I checked this once. Maybe not gonna check it again. Oh, maybe I should check this. So v du minus u dv. Yeah. Wait. I see my mistake. I need to fix this fast, guys. This is t goes away, but this is 2 plus 3. It's 5. At least I spotted it. I have time, but I'm just going to make sure here that that is a mistake. So, okay, yeah. So this is 5. Wait, hang on. This is a 5, right? Okay. So if t equals 2 there, okay, so dy by dt, let's check dy by dt as well. So that's minus 2t, so that's minus 4. dx by dt is instead 7 over, yeah, it's just 7, isn't it? Yeah? Right, it is 7. Yeah, okay. And then this is 7, okay. This is, the x and the y I think is correct. So it's x equals t equals 2, so 7 there, and minus 7 there. Y is also minus 3, yeah. Okay, so the gradient is instead, wait, I didn't have a minus there. Okay, so the mn here is just 7 over 4. This is then 7 over 4, right? So what do I need to multiply? I still multiply 4 in, but this one I get 7 and 49. 7 and 49, yeah? So this will become what? This is 7x, right? And 12 subtracting 49, I get 37 equals 0. Still have time. Yeah. Okay, that should be fine now. I hope that's not a follow-through. Yeah, because this is just Cartesian. So I think that's gonna be fine. Because that was yeah, I made x the subject, sorry, t the subject, and then sub back in there. I get the form. I should be fine, I hope. I got 2 minutes left. The vectors are fine, except if I do anything wrong with the b minus a, so 1 minus 3, yeah, so that was right, that's fine. And then I did ac, so c minus a, 3 minus 1, alpha 8, but the 0 goes away there, so I only have that. Yeah, so that's my alpha. I think I'm okay. Yeah, unfortunately. Okay, that's just, yeah, this one I hope is going to be okay. I only hope, right? I don't know. I don't have the mark scheme yet, so I won't be able to mark this, but I'll try my best to go through everything again, see if I made any mistake, and I'll just also post the work solution with some correction if there are mistakes, right? But then I'm gonna tell you also the marks that I get as well. All right, I'm gonna stop the timer now. All right, guys, I just used an AI model to generate a mark scheme here. It's Grok 3 from XAI, yeah. Well, let's see how well I did. I think I made some silly mistakes along the way, yeah. I checked a little bit there. Now, number one, so we're just gonna check the critical part. It's the answer to y here, part A. So y is minus 5 over 2 and 4, yeah. And then part B, right? So part B asks for the linear equation. And I'm going to check the last line. Right. So that is probably the linear equation. Yeah, okay. So if you have a look at my equation here, it's not the same, but it's out by a factor of 2. So I forgot to simplify that. I mean, the question doesn't say fully simplified, but I would say, yeah, to be harsh to myself, here I'm going to minus 1, because when I simplify that, I get 13y here minus 38x minus 33 equals 0. So yeah, I'm going to minus 1 here, just to be harsh, because there is no official mark scheme yet. All right, so they might or might not allow it, but I'm not allowing myself here. All right, guys, so minus 1 there. Question 2, yeah, I think this one is fine. So it got the same thing here, yeah. dr by dt is just that, so it's inversely proportional. Okay, number 3, solve the differential equation, right? Yeah, this one I made a very stupid mistake, and you guys might have spotted it along the way already. I forgot to divide by 2 here. How stupid, right? So I minus 1 here because that's not the exact form there. And that's a follow through, because then I take this and that, and so the y squared there would be a minus 1 as well. And I also forgot to sub the bounds. I blindly didn't see this at all. They gave you the bounds, like the conditions here where you can substitute and solve for this value of c. So I didn't solve that. Probably I lose another 2 marks. So that's horrible. I lost 4 marks here. That's the worst marks that I can get, right? Like that's the potentially the worst case scenario, if you know what I mean. Yeah. Probably get something there, or maybe 2 or 3, but there you go. To be the most harsh to myself, I'm just gonna take marks away, because I still get the right integral here, yeah. So I do get some marks. Yeah, that was still useful, I hope. Although I forgot, I made a silly mistake there. All right. Okay. This one, I think everything is fine. Yeah. I mean, looking at the constant, c is 2. Sorry, c is 8. B is 4. A is 5, right? So that should all be fine. Yeah, okay. Wait, where's A? A is 5, okay, that one. And then we get that, yeah, good. And then integrating, and then I'm just going to check the final answer here. 5 ln 2, 4 ln 3 over 5, yeah, I think so. So that's fine. Number 5, all right. So P is minus 7 minus 3, yeah, that's the P, but it didn't ask for the coordinates of P, yeah, so that was fine. And then I look for the linear equation down here. Wait, what? I didn't get it? I think I checked this one already. Still didn't get it, right? The normal is 5 over 4. Wait, what? Hang on. I made a mistake in substituting this. Okay. Right. So let's have a look at the dy by dt. Wait, that was x. Hang on. Dy by dt was, yeah, dx by dt is, oh, why did I have a plus t here? Oh no, that should have been cancelled. Oh, that's just horrible. That's horrible. I lost 1 mark here, but I did get a method mark here, I think, because I followed through there. Probably a method mark there. Probably lost another mark or 2 down here along the way, because I got all the methods, yeah. Okay, I'm just going to say -2 because this is all dependent marks and this is the final form. Horrible. I just got that wrong and everything collapses. Not good, not good. Silly mistakes. Maybe I got too excited. Okay, yeah, I accept my defeat there. Okay, right. This one, let's have a look if I got the right expression. Yeah, I did, so that was fine. X not equal to, you need to write that as well. Number 6, vector. I think vector was fine, so write down linear equation, sorry, vector equation. Yeah, I got, that is just one example, right? You can have other form as well. And let's see, alpha. So plus or minus root 4 root 2 and plus 2. Yeah, nailed it. Number 7. Transform that to that. I did. And then integral of that, I already turned it back to the x form. Yeah, didn't make that mistake there. Good. Number 8. Yeah, that was all fine. Part B. Yeah, part B. This is also fine, right? Wait. Oh, part B is here. Yeah. Part C. This is the answer? This is wrong then. Yeah, I think I made a stupid mistake about adding the coefficient of x squared. That should have been 1 over 128, but I got 1 over 64. I tried to do mental math, but see, I messed up with the calculator with the mental math together, and I got that wrong. So that should have been 1 over 128, right? Yeah. So I minus 1 here. And then I use that to find the approximation there. So I get some marks for the method, assuming that this is, okay, this is 3 marks. So I think I get marked for doing this, I think, and substituting in, although the final one was wrong. So I'm going to minus 1 there. Okay, so let's see, if I got this right, it would have been right or not. So it would have been 1 over 4 plus 1 over 128, right? So that would have been 33 over 128, yeah? And then if you rearrange, you would get, what was that? Wait, why did I have 4 here? That's bad. Anyway, okay, anyway. Yeah, I mean, that's fine. I still get minus 1 there. Okay, so it's gonna be, yeah, so the 3 cancel here, do you see? And yeah, if you flip the fraction, yeah, you get 128 over 11. Yeah, just got that bit wrong. Everything was fine. So the method still works, right? It's just that it's a follow through here. 1 over 64 there, that was wrong. So this is minus 1 again. Number 9, I think I nailed number 9 because, yeah, let's see. So A, B, C, hang on, where's everything? Yeah. So 1 over 2, 1 over 2, 2 over 5, 1 over 25, yeah. For part B, yeah, this is the loop integration, that's it. And then part C, yeah, 290, nailed it. And then the last one, proof, we're going to assume, yeah, we assume that, yeah, equal sign as well here, don't forget. And then I use the, yeah, I use the difference of squares there. And then I cancel that. Although I didn't do like x plus 45 though. But I consider, yeah, I consider this range. Yeah, I did a little differently there. But the point here is to get the idea of, so it got to this. But then what I did after this, that I squared the thing. So this is where I did it differently from the AI here. So I squared there. And then I could prove also that after I squared it, that is not possible. I think this still works. Yeah, absolutely. Yeah, so something to show that this is, you know, like the bound of this is kind of like less than, so it's showing there that this is less than 1. So it contradicts, right? Contradicts this statement here that is greater than 1. Yeah, so I'm also showing that the sign 2x greater than 0 here is not possible because sine 2x is in the, if you look at the bounds there, the 2x is in the third or the fourth quadrants. which is not a positive value. It's actually a negative value, so that contradicts as well. All right, so that's also fine. I think I'm going to mark myself here. Okay, so how many marks did I lose? You see, if it weren't for these stupid mistakes, I would have nailed 100% here. I mean, no flex here, guys, because it was just stupid mistakes. I think I got all of the questions. I could do all of the questions. There's nothing particularly too hard there when I did it, but just the stupid mistakes, really, that got me. Okay, so hang on, sorry. I'm just going to count. 1, 2, yeah. Three, 4, horrible. Yeah, this one is the worst. 8, I lost 8 marks, and 9 probably because I didn't simplify the first one. So 9 marks, right? So I got 66 out of 75. That's horrible. Only because of stupid mistakes, right? There you go. There you go. Okay, okay. So this is probably the worst P4 paper. Only due to the stupid mistakes. But okay, let's review the paper. I think this is probably about as hard as the October 2024. All right, which was hard. So if you guys wonder what's the grade boundaries, you can check that one. I think it's more difficult than January 2025, but is, I don't know, probably about as hard. I mean, if you have done both papers, you can compare, like how did you feel about the October 2024? Maybe harder, this one is harder, so maybe the grade boundaries are smaller, like lower, so you can benchmark on that one. But okay, let's review the paper. I mean, the first one should be fine. You got to be careful here because it's a lot of nested function. You got to do product rules, you got to differentiate, and don't forget to simplify that. Okay, I'm just taking my mark away here. Okay, the second one could be tricky if you don't know what to do, but it's just playing you with the definition of the rate. Yeah, and if you do the chain rule equation and you end up having dr by dt being proportional to 1 over r squared, this is just, you know, when you did IGCSE or GCSE, the proportionality, inversely proportional, yeah? So something being inversely proportional to something, we can write A equals K over B, right? And in this case, the B is the r squared, right? This one, well, yeah, I shouldn't have forgotten that. It's very obvious. I forgot to sub in the bounds. I should have, and I made a stupid mistake about the simplest integration you can get. Integrate y is y squared over 2. That is so stupid of me. Yeah, I'm just scolding myself here. Okay, but I get the right integral there. Although that hard bit I got it right, but I made mistakes, a lot of mistakes here, guys. This is the real deal here for me for question 3. All right, we all make mistakes, I guess. Yeah, but try understand how I got the. So I showed you 2 methods. Maybe I was getting a little too keen on these 2 methods that I could show you, and I forgot to complete the question. Yeah, that was bad. That was bad. All right. Question 4. Yeah, just pass your fractions. Everything should be fine. Just be careful when you sub in the bounds, right? Number 5, yeah, number 5 is unacceptable as well. It's like, how did I write t there on top of the thing there? It's like minus 2t cancel with 2t, and then I still wrote t there. So I got minus 1 there. I followed through, and then I got the I put everything into the equation, and yeah, I think I get all the method marks except the accuracy. So I lost 2 accuracy marks, I think. Yeah, for that. Yeah, this one. So, well, it's not that obvious to find the Cartesian form from the parametric here. because normally you would have trig equations, but this time it's just rational linear functions. So the way to go is, if you run out of options, you just make t the subject and then sub t to the other one. Okay, t being the third parameter here. And I did that and I got it right. Okay. This one, yeah. Well, I think vector is okay for this paper. It's not too hard. You just got to be careful with the alpha there. And not to expand this too early, because you can solve it by completed square. Okay, so I just follow the procedure there. Although you got an alpha minus 2 there, but don't panic. It's just algebra. So just, go through the process there. Should be fine, like the dot product and everything. Yeah. Number 7, I think, yeah. This is fine, right? Yeah, everything is fine here. So substitution. Now you have to be fresh about the trig identities. Yeah, they come up all the time. In almost like if you see a trig question, trigonometric question, yeah, it's mostly about using trig identities. Yeah, so bear in mind. Okay, so yeah, and I integrate that. Now this one, don't forget to change to the x form, right? Yeah, this one, just one silly mistake as well. Yeah, just binomial here. The tip here for the part B. Part B doesn't quite appear. Sorry, I mean part B here. It's just that this sign is just the opposite to that. So we just consider that if this was a minus x over 4 instead. And only the middle term changes, right? The middle term here would change. Everything else is the same. And yeah, I got a wrong number there, which is stupid there. And then it's a follow through there. I got a method mark, I think, because I multiply 3 over 3 here to make this root 135 as required. But then the final answer is wrong. And this one, yeah, this one is a big deal here. It might take a lot of time from you. So I spent quite some energy here to get everything right. Solid revolution, and then you need to multiply 2 to everything. But yeah, so the hidden gems here, one of them is the integration, the loop integration. So this appeared once in 2021. If you don't know how to do this, you're in trouble, because you're going to keep bipart integrating forever. Okay, so that was, make sure you understand that as well. And this is subbing in everything. I was very careful about this, and I got it right. All right. Okay, so the proof there, yeah. So you need to know that cos 2x is also that. Not only the 2 cos squared minus 1 or the 1 minus 2 sine squared, is also this, right? Got to know that, and then you can use that. And then, yeah. Now I went to a different path to the AI here. The AI just try to prove that cos x plus sine x itself is not greater than 1. But I just square both sides and I get 1 plus sine 2x and sine 2x greater than 0. So this is a positive, but if you look at the 2x domain, it's actually in the 3rd or the 4th quadrants. So it's not possible to get sine x to be a positive number. So I say the logic here that this is false, so it contradicts the assumption that we made it greater than 1 earlier. So that's the proof there. So guys, I think that's it for the walkthrough. I didn't do that well, but I hope I showed you all the clear methods to work on each question, although I made some stupid mistakes, but I think I'll annotate the video so that you guys know that I make mistakes there. And that was it. So if you haven't checked my other videos, so please do, and stay subscribed. And don't forget, guys, keep studying. Bye.